Hey, it's Jag. Let's see how far we get.
Yeah.
Well, as you just saw, I did get a cutoff wheel for my Dremel and cut the rod down. It's not the prettiest looking thing, but I can put this part at the bottom and no one will ever see that. Also, I made a magnet charging jig. I didn't really need that. I have for years charged my magnets using the jig that that the StewMac website has. I figured we're building the Highline Guitars CNC winder. Why not build the charging jig the way that Highline Guitars does it as well? And that's where you take two larger neodymium magnets. You orient them the same way. It's essentially the same process as is detailed on the StewMac site, and I'll just kind of run through this a little bit. I've used 1 inch by 1/2 inch by 3 inch N52 neodymium magnets. That is probably overkill for this, but I have a few ideas of things that I want to try out. It may end up being overkill, and if it is, I can use my my other charging magnet charging setup. At any rate, that's my new magnet charging jig. I have this little piece of wood spacer in here, and that will always go in there when I'm not using the jig, and I will tighten up the jaws so that it keeps the magnets where they are. If you've never worked with neodymium magnets, especially the N52s, they are very strong, and these two bar magnets, if they slammed together and your finger was in the middle, at the very least you would break your finger. I suspect you could actually crush the bone with these. So you need to be very careful with neodymium magnets. I use a pair of protective gloves. I wear eye protection because these magnets, when they slam together, they can shatter, and generally they shatter and immediately turn into a ball of shrapnel. But some of that could fly around, and you wouldn't want to get something like that in your eye. Or, like I say, you wouldn't want your hand to be in between two of them. I probably will epoxy them in here and do my best to make sure that those magnets can't jump out and slam together unexpectedly. Anyway, that's the tensioning rod and my magnet charging jig done. Well, I still have two more things to wire up in the tower before I can put that together, and we can consider the winder completely built. Those two things that I need to hook up are the stepper motor for the Traverse and the photo interrupter for the counter. I have to solder the photo interrupter and the 220 ohm resistor to the breakout board, and then I have to take 3 wires, red, black, and yellow, from the breakout board to the counter. The instructions say to cut all of the wires as close as you can to the board. We will be mounting this to the L bracket mount we made to set the photo interrupter over the bobbin plate. But we don't want to cut this too short. If you do, you risk cutting the pads off or scraping them off when you're cutting. And that wouldn't be a good thing. So I've got these cut pretty low, and I'm ready to wire this into the counter now. That's the wires for the photo interrupter screwed into the screw terminals on the counter. I need to take the winder panel, the DC motor panel, out of my way so I can wire the stepper motor into the G-shield. Well, I don't know a lot about stepper motors. The basic principle is similar to any other motor, except that a stepper motor has two sets of coils that are powered off and on very quickly in alternating succession to move the motor in very fine increments or steps. There are lots of videos out there you can check out that will explain how stepper motors work, but it's beyond the scope of what we're doing in this video today. This Traverse did not come with a wiring harness. This was actually given to me by a good friend of mine, Dale Winhold, who does a lot of playing around with robotics and CNC and inventing things. And when I told him I needed this 55mm linear slide, he said, "I've got one, you can have it." So saved me some time and some bucks. But it didn't come with a wiring harness, so I had to order one on Amazon. No big deal, it's a couple bucks. Since there are two sets of coils in a stepper motor, and there are four wires coming out, one pair of those four wires is for one coil, and another pair is for the other coil. And we need to know which pairs are for each coil. So I know three ways to test that with a stepper motor. It also tells you if your stepper motor is good as well, which apparently stepper motors are very robust and don't really fail that often. I know I have seen many very, very old stepper motors still working just fine in equipment in various factories and manufacturing facilities. So the way that I like to test the stepper motor and identify which wires make up a pair for a coil is to use a simple LED. Take the connector for the stepper motor, the connector that will go to the motherboard end, and we're just going to install the leads of the LED in connector pin 1 and connector pin 2. The polarity of the LED doesn't matter in here. For this test. This will work just fine. What we do with the LED installed in there is we turn the lead screw for the stepper motor, and if the LED lights up, we've identified a pair of wires. The LED did not light up there, so what I'm going to do is take the LED out. I will leave the one lead in the first pin, and I'll put the other lead in the third pin. And we'll see what we get there. If you can see that, the LED is lighting as I turn this. So we know we've identified a pair. The red and green wires are one pair going to one set of coils. So just to be thorough and make sure that we don't have any kind of shorts or anything, I'm going to keep that one lead of the LED in the first pin connector, and I'm going to put the other lead in the fourth connection, and we should not get anything lighting up when we turn that, and we don't. So now we know that red and green are one pair. Now I've connected that LED to pin 2 and pin 4 on the connector, and that should be our other pair, our other coil pair, and if we turn it, the LED should light, and it is lighting. So we know that black and blue are one pair and green and red are another pair. And as it turns out, that does match the color coding that are in the instructions that Chris sends out. So one pair being red and green and the other pair being black and blue. So we shouldn't have any problems with our wiring here. Another very simple way to test a stepper motor is to take a little loop of wire and put it into the pins on the connector. And if the lead screw gets hard to turn and you can kind of hear it, it makes kind of a rasping sound, you know you've also identified a pair. So I've got this little loop of wire in pin 1 and pin 3, which we did say is one of our pairs, and I'm going to turn this lead screw. And it's harder to turn, and I'm sure you could hear that kind of rasping sound. We'll do the same thing for the black and blue pair, which are pin 2 and pin 4, and we should have the same result. And you hear that. It's like a rasping or scraping sound. It was harder to turn. If I take that loop of wire right out and I turn the lead screw, it's very smooth and you don't hear that raspiness. And of course, the other way to check is using a multimeter. I've set my multimeter so that I get the continuity beep. And I'm just going to touch pin 1 and pin 3, which we did say was one of our pairs. And there, we've got continuity, so we know we've got one pair identified correctly. I'll connect it to pin 2 and pin 4, which is the other pair. And we got continuity. So we know that our stepper motor works. We know which wires are for the 2 pairs of sets of coils, and we're ready to wire it to the G-shield. In talking about that and describing how you test your stepper motor, we used the connector to put our LED, use our multimeter probes, the loop of wire, etc. But we don't need this connector to connect to our G-shield. The G-shield has screw terminals. So we're going to cut this connector off. Once we have that connector cut off, we can fish the wire through the hole in the fan side of the winder tower, and we can strip those wires and connect them up to the G-shield. I will do it following the color code that Chris has on the instructions, since my color, my wire colors seem to match what he says. Once we wire it, if we find that the traverse is not moving as we expect, I can change those pairs. I can swap those pairs to 2 different screw terminals, or swap them 1 for 2 and 2 for 1 and 3 for 4 and 4 for 3. So like I say, I'm going to go with the color coding that is in the instructions. And we'll strip those wires and wire them into the G-shield. And once that's done, I can put the tower together. So that's all the wiring done. I'm going to button the cabinet up, and we just have a couple of final things to do. I need to remount the live center. I need to mount the photo interrupter, and I need to attach the V bearings, the V groove bearings for the wire guide. The band has a term for what I do when I get into tech mode, when I start working on tech things, and the term is Jagensteining. So I am kind of known for making things work when I don't have exactly the part I need, and I've done a lot of that on this build. Everything's solid. I'm really happy with it. The last 2 things that I just came up with right now that I had to Jagenstein, one was the wire guide for these V-groove bearings. I had some standoffs and small metal machine screws that I thought were going to work on here, but they were too big for the holes in the V-groove bearings. So I Jagensteined and used some smaller screws and stacked about 4 washers to get the bearings away from the plate for the wire guide. And that's working out really well. And I put a jam nut on the back of each too to keep this tight, to keep the wire guide tight. It's not going to be subject to a lot of force or pressure. Pickup coil wire is very thin and very fragile, so this should work really well. So I Jagensteined that. The other thing that I Jagensteined is Chris says to use hot glue or epoxy on your mounting bracket for the photo interrupter. I was going to do that. I do have, I don't have any epoxy right now, but I do have a hot glue gun. But then I remembered I had this Gorilla Glue. It's kind of this Gorilla Tape. It's kind of a gel tape, and it's a double-sided tape. And I used it to, actually I used it to stick down a phone holder in my vehicle. And when I had to take that off, it almost tore the whole dash off. So this stuff sticks pretty well. It's about maybe a 32nd of an inch thick. It's kind of a gel glue, so it does have a little bit of give, but I don't think so much that that's going to be a problem for the photo interrupter. If it is, I'll break out my hot glue gun and put that on here. But that was my other Jagensteining. I've got this mount on upside down right now just so I could stick the tape to it. I need to turn it back around, get the photo interrupter adjusted so that the bobbin plate centers in it, and then I've got to stick it on there. The main thing about the photo interrupter is the bobbin plate has to be centered between the pathway, and the photo interrupter has to go down low enough that the little windows in the in the bobbin plate, the photo interrupter can actually see through those. The whole mechanism is two-sided, and it sends a beam through here, and as that's broken, when the bobbin is spinning, or when the bobbin plate is spinning, that's how your counter knows how many winds you have. This could be a little bit finicky, I think, to get on in exactly the right way. This is kind of a critical piece, so I do need to get it right. Yeah, it looks like it's going to work out quite well there. Setting this down, actually as far as it will go, looks exactly right. I have centered the photo interrupter. That Gorilla Tape seems to be holding it fairly solidly, so I think we're good. So I'm just going to tighten this mount up. I've got one other thing, kind of a mini unboxing. I'm sure most of you can guess what it is if you've been following along on this build. There's one other thing I haven't installed yet. When I did the first episode of this series, the one where I listed all the parts and showed all the parts I had, one of the things I said I wasn't able to get was the magnetic tensioner that's specified in the plans, and I was going to make a tensioner. Well, I'm kind of like a dog with a bone for that kind of stuff, and so I kept searching and looking and searching, and finally AliExpress came up with the magnetic tensioner. It was available, and it was not the $250-ish that it looked like it would have been if I had been able to get it through Amazon.com, which I couldn't anyway. They wouldn't ship to Canada. At any rate, I got this on AliExpress, all in, shipping, everything else, for 80 bucks. And it is the actual magnetic tensioner that Chris specifies in the instructions. We've got the magnetic tensioner, and the tension, the arm that the wire goes through, and the mounting little screw for mounting it to the rods. The tension arm has a little set screw, and there's a flat spot here that set screw is supposed to screw into, and the rod comes up like this. I noted that in the build instructions, Chris says to place the rod horizontally. So for now, I'm going to do that. I don't need to worry about that flat spot. I'll just set this horizontal, tighten it up with an Allen key, and if I come up with a reason to change that down the road, I can do it. That looks pretty good to me. I'm just going to put it on the winder, and it's built. And it looks the way it should. So like always, thanks for watching. Please like and subscribe. Check out my band One Soul Thrust. The links are below. And until the next video, we'll see you.